Suppose a plus b plus c equals to pi radian. We need to show that sine squared a minus sine squared b added to sine squared c that equals 2 times the product of sine of a cosine of b and sine of c. Let us begin our proof from the left hand side. So on the left hand side we have sine squared a minus sine squared b added to cosine squared c. Fine. So we begin by first combining the first two terms. We have a standard formula for it. Sine squared a minus sine squared b. So that's given by the product of sine of a plus b and sine of a minus b. Okay, so that means our first two terms combines to give us sine of a plus b times sine of the angle a minus b, and then we have the term sine squared c. Okay, now here what we'll do, we're going to change sine of a plus b by taking the help of the given condition. That means a plus b plus c, that is equals to pi radian. So we can also say a plus b equals to pi minus c. Now we're going to take the sine function on both sides. So sine of a plus b, that's going to be equals to sine of pi minus c. So sine of pi minus c, that simply equals to sine c, meaning we can replace sine of a plus b with sine c. So sine c multiplied to sine a minus b added to sine squared c. So let's take sine c as the common factor. So sine c as the common factor. Once we take it, that leaves us with sine of a plus a minus b in the first term and sine c in the second term. Now what we do is we keep sine c as it is, sine of a minus b also intact, but what we'll do here, we're going to change sine c back to sine of a plus b. So we have plus sine of a plus b. Okay, now we know we can easily combine the two sine functions. There's a standard formula for it. So that's going to give us 2 times sine of angle A times cosine of angle B. So here we have used the fact, that means sine of angle C added to sine of angle D, that's given by 2 times sine of C plus D over 2 multiplied to cosine of C minus D over 2. So in our case we have considered a minus b to be d and a plus b to be equivalent to c, and this is exactly the expression on the right hand side, hence proof.